Well, good after evening, noon, everybody, and welcome to the Ham Radio.
Your
cards, even wow!
Your cards.
See, gosh, I'm sorry. I don't even
Excuses.
I didn't even think about it, and then all I saw was Vince's face looking at me like, oh my God, I am so proud of him.
So,
yes, I know.
All that requires.
Oh, golly.
I have a tear coming down my face.
Well, hey, everybody, welcome to the Ham Radio Kids Table. We are back here on another Wednesday night, and tonight we have Mark, November 6th. Fred? No, Bruce. We're going to call you Bruce tonight, right? All right. Mark.
We're all Bruce's tonight, just to keep things simple.
Okay, absolutely. Bruce, November 6th. Oh, gosh, dang it. Mike, Mark.
It's on the screen.
Thomas.
It's on the screen.
Thomas.
Mike Tango Sierra.
Oh, yeah.
Thomas Smith.
I am in the Initials Has Call Sign Club. Mark Thomas Smith.
There you go.
November 6th. Mike Tango Sierra.
Darn it. That was going to be the giveaway question was if anybody could pick your middle name out.
No.
But, no.
Well, too late.
I was going to see what kind of T names we were going to get to go along with Mark. But everybody, Mark from Halibut Electronics is here with us. What'd you say?
Would you say Freddie? Freddie Mac?
I said Tiberius.
That was one of the things I was thinking of when I was putting that together. It's like, what if he's a Tiberius? But
alas, my parents were not that nerdy.
Oh well.
So if you've been around the ham radio community for a while, you've probably stumbled across something Mark has done. I first stumbled across Mark when I was having common mode current RFI problems in my shack. And I found a video where Mark was doing a presentation, and I'm going to guess it was probably something that was recorded during COVID for one of the many online ham fests and activities. And
QSO today, Ham Expo.
The Ham Expo, yeah. Mm-hmm. And actually, it kind of I'm moving some stuff. I hooked up a new antenna, and I started having some RFI problems. And I thought, you know what, this would be a good conversation to get Mark back in here and talk about that a little bit. But before we do that, Mark, could you tell us a little bit about yourself and some of what you've got going on?
Sure. My name is Mark. I'm 6'2", 350 pounds. I like long walks on the beach. And that's not what you meant.
No.
Mark, I sometimes go by Smitty. Halibut has been kind of my brand since I was a kid. I won't tell the story here unless you guys ask, but it's boring. It basically roots in just for the halibut. But I've been a ham since 1992. I've always kind of had electronics as a hobby. But my primary career was doing IT work, network engineering, system administration, application administration, a little bit of software development, that kind of stuff. I generally summarize what I did as I make the internet work. And I did that for 30 years, long darn time. And then stuff happened in 2021. I won't go into those details here, but I started a electronics company called Halibut Electronics during a global semiconductor shortage because that seemed less stressful than what I was doing at my day job at the time. So my first product was this common mode current choke test rig that we'll be talking about tonight. Because I gave that presentation at the QSO Today Ham Expo talking about common mode, and I wanted a way to be able to measure the chokes that I was talking about. And so I designed, or I kind of hacked together this box to be able to do those measurements. And the most common question I got from that presentation was, where do I buy that? And I'm like, no, I'm not in the business selling kits or anything like that. So I didn't want to get into that business. And then just a few months later, wackiness ensued. And what do you know? I am in the business of selling kits. So that was the first kit I put together.
And it's actually a good kit. I own that kit. And I did a video. It's probably been about a year and a half, maybe almost 2 years ago, on testing common mode current chokes and their effectiveness. And it kind of, because I like to teach through demonstration, Mike KMRD had a video where somebody had asked about the chokes that are on the end of ABR coax. And, is 2 better than 3? Is 3 better than 4 or 5? And I figured, you know what, that's a great question. And I used that as the premise for that video. That's probably been my most viewed video. And it's great knowledge to have in amateur radio. I mean, you're not getting away from common mode current. So how do you deal with it? And, there's tons of chokes out there, whether you buy one or build one, how do you know it's effective? And so that's where something like this comes into play.
Yeah. I saw lots of conventional wisdom that and because we'll get into this when we get into the technical details if we want to, but common mode is not easy to measure because it's what we don't want. We want differential mode, which is the other kind of current. And all the differential mode is on the inside of the coax. And that's really what we want in all cases. So all of our test equipment is doing differential mode because that's the kind of current we want. Measuring common mode on the outside of your coax, that's kind of the whole point of coax, is to keep things on the inside. So none of our test gear is measuring stuff on the outside. And so there's lots of conventional wisdom about what kinds of common mode chokes to use and build and how you build them and all that. And I wanted to be able to measure those different designs. And I found that some worked and some didn't. So, yeah. I've left you speechless already. And Tim's muted.
Well,
and Tim is locally muted. So, Mark, I mean, the great thing about that common mode current choke test rig, did I say it right?
Yes.
Oh, man. So the background is like in 2023, Mark and I stood in the booth together, and I had to learn how to say that. And I'm afraid every time I say it, I'm going to screw it up.
I am terrible at naming products. We'll start with that.
But the wonderful thing about it is it just makes it kind of like a one-stop shop to loop in the choke under test and get it out to your NanoVNA or the Russian version, the NanoVNA, or your favorite VNA, to see exactly what the curve is. Right? It's brilliantly designed, and the newest version of it. I mean, you've come out with 3 versions, if I remember now.
It's version 3 only because the first 2 that I designed for the presentation, I called them V1 and V2. So the only version that I've ever sold was a version 3. There have been a few very minor changes to version 3. But yeah.
And they've got, 50 ohm dummy loads on them and non-inductive dummy loads and all the rest. Yeah, it's been a fun little build for you.
Yeah, I've sold hundreds of them, if not 1,000 at this point. I haven't actually gone back and done the math. Although I did go back and look at the box of stock and realize that I'm running out. So it's about time for me to make another batch. So,
well, maybe, if you go back and do the math and you see unit number 1,000, it has like a special
signature on
a special signature on it, or some gold leaf on it, or something, right?
I'll probably throw a couple of extra stickers in the bag. How's that?
Yeah, that'll work.
Or a golden ticket, maybe.
Yeah, exactly.
A golden ticket, yeah.
Golden ticket.
Tim, how's your audio working?
Pretty good.
Yep,
I think.
Good. Perfect.
Yep.
Good.
Yep. I just can't touch the table right now. So hands are in my pocket.
Can't touch the table.
Yeah, there's a loose connection between my computer and the mixing board. So.
Oh, okay. Usually it's a loose connection between the seat and the keyboard.
Well,
so I'm glad to see that's not it this time.
My brain in my mouth. So
yeah.
There's a loose wire, a broken wire somewhere.
Yeah.
Well, hey, I just noticed you're starting to get some questions in the chat. So if you've got questions, please get those in there. And we'll get them marked and kind of go through them here just in a little bit.
Eric's got a great idea for you, Mark. Scratch and sniff stickers that smell like new radios or magic smoke.
I love the idea of a scratch and sniff sticker that smells like magic smoke.
Yeah,
I do love that.
Yeah,
that's a pretty cool idea, actually.
That smell you just can't get out of your head once it's in there.
Yeah, I gotta go figure out how to make scratch and sniff stickers now.
Especially Magic smoke.
Yeah.
I was gonna say it's kind of like the. Are you familiar with was it the Bernie Bott's beans or whatever
Yeah.
from Harry
yeah.
Potter? Right, all the different
Bertie
flavors.
Bott's
And
all flavor beans.
yes, and you never know what you're gonna get, and some can be really pleasing and some not so pleasing.
Magic smoke would be one of those non-pleasing smells for sure.
No, or taste.
don't ask me why, but from last week I still have magic smoke stuffed up my nose. So yeah,
Okay.
That's too bad.
That seems like something
a
you don't
shower
want
every
to
once in a
get
while,
around
Frank.
the
Campfire.
Yeah, you might want to go see a doctor about that.
well,
If you've had that smell in your nose for more than 4 hours,
Go see your doctor.
you need to see a doctor.
Wow.
Freddie,
Well,
you'll commiserate with this one.
Tim,
When a
you've been
Motorola
trying to
decides
ask a
blow up.
question. You've been very polite.
Yeah, golly, I'm sorry. So I think one thing that one thing that everybody deals with in generating how does, or I guess the one thing everybody probably has that they use that is probably the most common cause of common mode current is, and would probably be coaxial cable for feed line. Or at least that's my opinion, because it's an unbalanced line to begin with. Or am I wrong on that one?
So the unbalanced in the way you're talking about it is referring to voltages, and this is a current thing that we're talking about.
Okay.
They are so that's why it's called balanced and unbalanced when you're talking about voltages, and then common mode and differential mode when you're talking about currents. You can have differential mode current, which is the good kind that stays on the inside of the coax, even with a single-ended or unbalanced signal. So coax can still have differential mode currents. In fact, by default, it usually does. There are two different types, or excuse me, in ham radio, there are generally two different categories of common mode currents that we want to try and eliminate. One is while transmitting, and the other one is while receiving. The transmit common mode current is when your transmitter puts out a bunch of differential mode. It's on the inside of the coax. It goes all the way through your coax up to your antenna, and it hits your antenna, and now your antenna is not perfectly symmetric. And when you have a non-perfectly symmetric antenna, one side is going to radiate better than the other side, and the other side will have another path for current to flow down to your radio through ground and out to the rest of the world. And I'm kind of hand wavy here because the exact model of this is somewhat complex, and I'm not even sure I fully understand it and all that. But when you get to your antenna, if you have a perfectly symmetric dipole antenna in the air, then you're not going to have any common mode currents coming back on the outside of your coax, because it will all be radiated by your antenna. However, there is no such thing as a perfect antenna, a perfectly symmetric antenna. And so you'll always get some amount of current coming back down on the outside of your coax. Now, this is different than reflected power that your SWR meter will read. That is still differential mode that is reflecting back on the inside of the coax. That's all still differential mode. So common mode current will not show up in your SWR meter. There's nothing in your radio or your shack that will measure common mode current, because, again, like I mentioned earlier, common mode is what we don't want, right? All of the other things that we're talking about are differential mode on the inside of the coax, and common mode is on the outside of the coax. And so if your antenna is really non-symmetric, then you may get a fair bit of common mode current coming back down the outside of your shield while you're transmitting. And that can cause problems. If you've ever had tingly lips when your mouth touches the microphone, or you felt a little bit of RF in your hands while transmitting, or your lights start blinking, or some device drops off of the network, or you get buzzing in your audio cables, like all of these are signs of RF coming into your shack and doing bad things in your shack. And that is usually through common mode coming back down your coax. And so we want to put a common mode current choke to stop that at the feed point to the antenna. And what that does is that makes that the common mode, the outside of your coax, it adds a whole lot of impedance to the outside of your coax and makes that the no longer preferred path for that RF power. And it will keep it all on the antenna side of that choke. And it's not very efficient, but it still does radiate out that way. Then the other time we have common mode currents that we don't want is on receive. The outside of your coax acts like a giant wire sticking out from your antenna, from your radio, from your receiver. And if that wire happens to be running right next to an LED light controller, or I don't know why, but washing machines seem to be a common source for RFI, common noise source. Some other source of noise around your house. And if it's right near that coax, even if your antenna is 100 feet away, but if the coax runs right near that noise source, you'll get a lot of that noise in on the shield of your antenna. And when that energy comes down and hits the feed point of your radio, if you had a perfect ground, 0 ohm ground, superconducting ground, all of that current would just go straight to ground and it would never touch your radio. But again, there's no such thing as a perfect ground. So whatever that impedance is between the shield of the coax on your radio and the negative power supply, whatever that impedance is, that current coming down, that common mode current coming down the outside of your shield through that impedance will create a voltage, and that voltage shows up in your receiver. And so you will get whatever that signal was in your receiver, and it creates a whole bunch of noise in your receiver. So you want to put a common mode current choke at the feed point of your radio as well. And again, that effectively disconnects the outside of the coax from your radio. And it can lower your receive noise if you're getting receive noise in that way. So the TLDR is stick a common mode current choke at the feed point to your antenna and another one at the feed point of your radio, and that will fix a lot of problems.
So
Okay.
WD0A and B over on Vince's chat wants to know, are you into audio? Radio engineering is one of his favorites at audio frequencies. JDI duplex is a masterpiece.
So I am into audio. I didn't get the whole question. Say that again.
Smitty. Go ahead, Frank.
Yeah.
Sorry. Or
Smitty,
Bruce,
are you
excuse
into
me.
audio? Radial
Engineering
is one of his favorites at the audio frequencies. JDI duplex is a masterpiece. There we go.
Okay, so I have never heard of radial engineering. I will check them out. I'm not going to go read it right now, but
Yep.
I'm going to keep it up in a tab, so I'll go look at it later.
So there
not
was
familiar with that though.
There was a couple quick questions here. Does common mode current vary with frequency?
Yes. Common mode current is at a frequency, right? The current you're getting, just like your transmit power or your receive signal or whatever, it is at a given frequency. When you transmit at 14.1 up to your antenna and your dipole is not perfect, and some of that current comes back down on your coax, that will be at 14.1 megahertz. It'll be at the same frequency that you're transmitting on. On the receive side, yeah, I mean, it's like wherever your noise source is, it'll be the frequency of whatever that noise source is. Now, common mode current chokes have a different effectiveness at different frequencies. So I'm not sure whether you meant common mode current or whether you were talking about the choke itself. But the choke will have different effectiveness at different frequencies, yes.
Okay. And the other question, James KI5OEB asks, my in-fed random wire seems to have more common mode current than my in-fed half wave. Is there a reason for that?
Yeah, your random wire is non-resonant. If you were to put a matching network at the feed point between your 50 ohm coax and your random wire antenna, instead of having that matching network at the radio, right? You have the radio, then you have coax that goes out to your 9-to-1 impedance transformer, and then a random length of wire, right? That 9-to-1 impedance transformer is just taking the wild and crazy whatever impedance that antenna is. It's non-resonant, so we have no idea what it is. Could be really high, could be really low, could be really reactive, could be really resistive. No idea. But that 9-to-1 brings whatever that impedance is down by 9 times. And it makes it a smaller impedance. And then we send that over the 50 ohm coax to the tuner in your radio. A tuner in a radio is more accurately described as a matching network. It doesn't tune anything. Your antenna is no more resonant than it was before. All it does is it takes whatever that complex impedance is of that antenna after being transformed by that 50 ohm coax and matches that to the 50 ohm impedance of your transmitter. And so in this case, the only thing the tuner is doing is saving your transmitter from an impedance mismatch on the antenna. So because of that, we've got all kinds of asymmetry at the antenna, and all kinds of currents are going to be flowing all over the place. It's going to be wild and crazy. If you were to take that tuner and put it at the feed point of the antenna, and match your antenna to 50 ohms resistive, like the coax is and your antenna is, you might get less common mode current, because it won't be all herky-jerky all over the place when it tries to go over the coax. I would still recommend putting a choke there at the feed point of the antenna, but yeah. The tuning network at the radio with a bunch of coax and then a random wire, that's always going to be a compromise. You can put a common mode current choke at the antenna if you wanted, but it's the random wire is going to be using that coax as part of the antenna system, which is inherently common mode. So maybe you have your 9-to-1 feed point with your random wire sticking out over here, and if you have a counterpoise wire, then put the common mode current choke right at the feed point, because then those are the two legs of your antenna. If you don't have a counterpoise wire, then let the outside of your coax be that counterpoise. So have it go down 10 feet or so of coax, then put your common mode current choke, and that will disconnect the rest of the coax from the antenna, and only that 10 feet or so will be the counterpoise. And then you'll stop the common mode current on the rest of the feedback, the coax down toward your radio. Did that make sense?
It did. Absolutely. Okay. So Don, N5 SKT has, it's probably more of an observation, but it says, it's funny how little common mode current I get since my antenna has moved over 100 feet away from the shack.
So I would be really interested to measure the common mode closer to the antenna. You may not be getting common mode, or you may still be getting common mode, but there's a fair bit of loss between, over 100 feet of coax, right? Like that common mode is going to suffer the same loss, or it'll be a different loss, but the same kind of loss that your signal does going down 100 feet of coax. And that will make it look like less when it gets to the radio. Same thing happens with SWR, right? If I'm outputting 100 watts and I got 3 dB of loss on my coax, only 50 watts makes it to my antenna. But let's say, I don't know how the ratios work out. Let's say the antenna is reflecting 10% of that back. So I got 5 watts coming back from the antenna, but then I've got another 3 dB of loss. And so I've only got 2.5 watts back at the radio. So the radio is transmitting 100 watts and seeing 2.5 watts of reflected power. So it'll think that's, what is that? 1/80th? Quarter, 40th? 1/40th of the total powers, whereas my antenna is actually reflecting 1/10 of the power, right? So long feed lines can make things look better than they actually are.
Flat across the band, eh?
That's right. By the way, hi, Carlo.
Look at Carlos. Carlos just jumped in tonight.
Yeah.
What he does.
I couldn't make it last week. I tried. The only reason I'm able to be here tonight is because the YL is out visiting family, so I get to play hooky.
There you go. I thought Wednesdays was leg day.
Well, leg day is every day. I lift on
Okay.
Tuesday, Thursday, Saturday, and Sundays, and every day is a leg day. You always squat.
Yeah, don't skip leg day.
Never.
James is making me feel a little awkward.
Uh-oh.
He just said Mark is my hero, or Smitty is my hero.
Oh,
Although it looks like I was looking at the wrong end of the chat list. Never mind.
So, actually, one of the reasons I'm here is I tried making it last week. I really enjoy talking to Ray. And I saw that you were in here tonight. I'm like, I gotta make it because, again, to make you feel awkward, you're one of my favorite people in ham radio. So I had to make sure to come in here, give you a little bit of grief.
Thank you.
So Pepe has a good question for you. Can he measure this common mode as a non-professional?
Can you measure the common mode current? Measure the current itself as a non-professional? I don't think anyone's going to care whether you get paid for it or not. Physics doesn't care whether you get paid for it or not. But can you measure common mode? So we can measure the effectiveness of a common mode current choke really easily. Measuring common mode current is slightly more challenging. I have not actually built one myself, but I have been told that a way to measure common mode current is by taking a clamp-on ferrite, right? Like these are the things that we use to build chokes, right? So you take a clamp-on ferrite and you get some magnet wire, the kind of thing that you would use to wrap a toroid, small magnet wire. And you wrap a bunch of turns around one half of that ferrite. You got two C-shaped parts of the clamp-on, right? They kind of open up like this. So if you take one of those C's and wrap a bunch of magnet wire around here, and now I've got two ends of magnet wire sticking up, solder an LED across those two wires. That is a common mode detector. And you clamp that onto your coax, and if there's current flowing on the outside of the coax, that will be a 1 to however many turns you put on that magnet wire transformer. So let's say you wrap it around 10 times. It'll be a 1 to 10 turns ratio transformer, which will take that current and turn it into a voltage through your LED and light up the LED if you've got common mode current. It's not a very precise measurement. It'll tell you whether you have current or not, and the brightness of the LED will kind of tell you how much you have, and you can adjust the sensitivity by wrapping more or fewer turns on that toroid. So you might want to have multiple toroids, high sensitivity, a medium sensitivity, and a low sensitivity one. The low sensitivity might only have 5 turns, and the high sensitivity would have 10, or the medium would have 10, and your high sensitivity would have 15 turns, or something like that. And then you could kind of use that to clamp on different places of your coax to see whether you have common mode on your coax or not.
Couldn't you, instead of putting an LED on it, tie that magnet wire to a sensitive voltmeter and just track the voltage?
So yes, most voltmeters won't measure RF. What you need to do is you need a way of turning that into a DC voltage.
Well, and that's what we're doing by doing the turns, and that's how you're getting the LED to light up, because the LED needs 3 volts to light up, if I remember right.
Yeah, if you use a red LED, it's usually about 1.2 volts. It doesn't need much. That doesn't convert it to DC. The transformer takes the current and changes the impedance of the current. So it takes the power that's coming down the coax and makes that power more voltage than current. When you go up in turns ratio like that, it makes it a higher impedance. And that higher voltage is what gets past that 1.2 volts forward voltage drop across the LED. And the LED is what actually turns it into DC. So the LED will only conduct half of the time. Actually, less than half the time, because every time it's a negative voltage, the current wants to go the other direction. It does not conduct. And then it doesn't start conducting until that voltage gets up to 1.2 volts. So it will only conduct anytime that voltage is over that 1.2 volt threshold or whatever your forward
Mhm.
voltage of your LED is.
Okay.
So
That's interesting.
if you wanted to hook it up to an oscilloscope, something that could see the RF, that would definitely do it.
Okay.
And you'd be able to measure the voltage of the common mode after it's been transformed by that 1 to however many turns transformer, and you could do that to measure it.
And I'm assuming use the number of turns as the multiplier.
The voltage multiplier would actually be the number of turns squared.
Squared. Okay.
Yeah. So the impedance transformation is the square of the number of turns. So if you have a 2-to-1 turns ratio, it's a 4-to-1 impedance ratio. Or if you had a 10-to-1 turns ratio, it would be a 100-to-1 impedance ratio.
So there you go, Pepe. I hope that helps answer the question for you. And Carlos, apparently Don didn't see your subtitle correctly. He thought it said Chief Gravy Tester.
I do like to test gravy. Gravy is delicious.
Gravy is
And thanks to Arnold Grubbs. He mentioned in over in one of the chats that Smoke and Ape did a how-to video on how to build that little thing that Mark described, and that name of that video is Easy DIY Ham Radio CMC Meter for Cheap.
Nice.
Awesome.
That's over on your side, Vince.
Hey,
Yes,
Frank,
it is.
Can you grab that and put a link in the chat? And now, of course, when Frank posts that, everybody has to go watch it after the live stream. Of course.
Yes.
And
Yes.
Mac, we are of course talking about Decepticons because they are the best Transformers.
Yes.
Yeah, Mike, why aren't you in here?
Well, Mike's got some family stuff going on tonight.
Okay.
Yeah, indeed. I tried building one of those little CMC detector widgets, and I didn't get anything. And then I later learned I had ground looping problems. And RF in the shack, but not common mode.
Yeah.
So that was kind of interesting.
See, anytime I transmit on 80 meters, my garage door opens. That's
Well, the other thing to note is that RF in your shack is not always common mode or caused by common mode. You know,
Right.
you have an antenna, and that antenna is putting out a whole lot of energy, and there are wires in your shack, and those wires can receive that energy. That doesn't mean that it's coming back down the outside of your coax into your shack. It could just be that your antenna is radiating into your shack. And that kind of stuff is improved by grounding and shielding and whatever else. But
Wrap your
RF
shack in tinfoil.
Yeah.
And ground it.
That's about what
ground
I'm
the tinfoil.
ready
You know-
to do.
You know, living in Indiana is kind of easy. My garage is made out of metal, and it's got a metal ceiling and it's a big ass Faraday cage. So I ground that wall and I'm good to go.
That's right. You ever see the movie Enemy of the State?
Oh yeah.
Oh yeah.
Yeah, where he's got that copper mesh room that he does all his work in.
It's starting to become a reality nowadays.
Yep.
So
Questions. Yep.
yeah, I was just going through here, and I was thinking about the common mode current choke test rig. Where can people find these?
electronics.halibut.com/CMCC or CMCCTR. Just go to electronics.halibut.com. It'll be on the homepage.
It's a great little kit.
And
It is.
Jeff dropped the link a couple times. I've dropped the link a couple times. So if you missed it, that's your problem.
No, Frank, come on, be a little bit more accommodating than that.
Yeah.
Nobody
We're
likes
sorry, it's your problem.
Don't
But
be
the
an
fact
Alpha
that I drop
Hotel.
it 3 times in a row back to back, and Jeff's
No.
done it. Jeff's done it like 5 times now. Thank you. So there's like 7 back to back. If you miss it, something's wrong with chat.
And I did it 5 minutes ago, too.
Right.
So actually, something I will point out, Vince, you were talking about getting RF in cables that were not your coax cables, like audio cables and USB
Sure.
and whatever else. I also sell a version of the common mode current choke test rig that I call my digital version, where it's the exact same thing as the RF version, but it has different connectors on it. So if you ever need to build a choke on an Ethernet cable or a USB cable or an audio cable, 3.5 millimeter audio cable, or Anderson power poles, the digital RF or common mode current choke test rig kit has all of those sockets on it. So you can measure chokes on things other than coax.
I was literally working with that kit today.
The
Okay,
digital?
so Tim, would you please bring up my screen share? According to Jimmy, PRK Radio, the site is down, but it's up. It's good. It's
Yeah, I got it too.
You might want
I
to try to
would-
reboot your computer.
yeah. Try
Yeah.
rebooting your computer.
Unplug it, plug it back in again.
Have you done a factory reset?
There you go, Tim.
I would upgrade your
Pick it up and
firmware.
shake it.
Have you
Tim-
nuked and paved yet?
Tim, RM-RF. Sorry, never mind.
Yeah, RM the RF in your shack.
Yeah.
Follow this
Yeah.
command line.
Don't forget the star.
Make sure you sudo it first, though.
Yeah.
Don't forget the star. You want to get all that RF out of there.
Now, is it sudo or pseudo?
It's suited.
That's what you ask.
It's whichever one makes you a sandwich.
There you go.
Does a super user do sudo?
Sudo.
You
Sudo.
said pseudo just a second ago.
I say it both.
Studio.
Pissed off.
Yeah.
You say tomato, I say potato. Okay.
Okay,
Disgusting.
but we all agree on coffee, and that's the important part.
There you go.
Amen, brother. Preach the word.
Nighttime coffee. Yeah.
So Jason Lockwood's saying that his infit halfway turns on his headlights in his car.
Oh, nice.
So real quick in the chat, if you've experienced common mode current in your shack or when you're out doing a portable operation, drop in the chat something that it's turned on or done. I think I'm like Steve K4 AFL down in South Carolina. His oven turns on when he's on 40 meters.
Yeah.
Well, that's helpful if he throws in the chicken fingers, then keys up on 40. I mean, he doesn't have to go to the kitchen twice.
There you
Yeah.
go.
Yeah,
Very
the
helpful.
LED string lights that my daughter has in her bedroom start flickering something fierce when I try to key up on 40 meters.
You know what's interesting for me anyhow? I have issues like this every once in a while in my shack where I get common mode in the shack and weird things happen. I don't ever experience that on the field.
No,
No.
I'm also curious how. I mean, it's very important to ground your shack. How do you do that when you're jumping out of an airplane?
Well,
Really long cable.
Yeah.
I drag a static line down.
There you go.
All right, kids, cover your ears. I think it's the brass balls that he's taking out. The plane.
So
I'll go for that
Eric,
one.
Eric says his 80-meter infed shuts off his neighbor's solar panel inverter.
Cool.
Oh darn! Ain't that a terrible thing?
That's a hell of a way to eliminate some RFI.
Right?
And done.
Let's see here. Brian, 40-meter transmission turns on neighbor's Christmas lights. Well, Brian, if they have their Christmas lights up at this time, it's a little too early for Christmas lights.
And serves them right. Keep
It's
keying up.
Spooktober right now. And for those that don't watch Josh during the after chat on Ham Radio Crash Course, Don mentions Josh sets off the smoke alarms on 40 meters when he does. I don't know if it's barefoot or if he runs the amp when that happens.
Jason.
He might just need to change the battery in a smoke detector. That's why it's chirping.
Jason says Carlos doesn't ground. He's always got potential.
There
well,
you go.
you ain't wrong. Let me tell you. It's called gravity assisting me. It's always adding potential energy to my system.
That is true.
Yeah, Don, that's what I thought. With the amp is Josh. And then, I was just going to mention that one. Andrew says someone's Halloween decorations are lighting up his 10 meters.
Yeah.
Well, hey, Mark, we've been talking about the CMCC a fair bit. Looking forward, what can't you talk about that's coming up?
You heard it here first, folks.
So I'm actually starting to talk to customers a little bit about this. You familiar with Halibut?
Yeah.
Sure, the widget that plugs into the computer that lets you do remote CW. Oh, no, I'm going to butcher this too badly. Yeah,
You got it.
it fits into your computer and lets you do CW over your Flex.
Yes.
Yeah, that's
Yeah.
what I
So
heard,
it is a FTDI serial chip, and it connects the tip and ring to the CTS and DSR flow control signals on the FTDI serial chip. So Flex Radio in their documentation says, go out and buy a USB to RS-232 adapter and then connect these things to these pins and hack together your own solution. And I'm like, well, that's dumb. Let's
Thank
just
you.
go put it into one of these things.
Thank you.
So that's Halibut V1. But I wanted to be able to do more than just serial because iOS does not give you access to a serial port on the phone. And so it will never work with iOS devices, iPads, iPhones, Smart SDR there. And same with browsers. Browsers can get access to a serial port, but I don't think they can get access to flow control signals. And so remote ham radio and Smart SDR for Mac and iOS and all that, they have kind of defined MIDI sequences that are used for triggering various different things. And so I wanted to add MIDI to Halibut, but you can't do MIDI on a FTDI serial chip. You need a microcontroller to be able to do MIDI. And so I replaced the FTDI serial chip with an RP2040, the Raspberry Pi microcontroller. They're about $1 a piece. They're redonkulously powerful. And they work great for this use case. While doing so, they URP microphone kits.
Yeah.
I'll have to look at that one in a second. While doing so, I had to go add some functionality to the tiny USB library that all of the Arduino world uses because they had the ability, they implemented the ability to trigger some flow control, but not all of it. So I had to go in and add the ability to trigger the other flow control signals that I wanted to use. But the USB specification, the CDC part of the USB specification, which is the serial port, we're doing USB. We're going to make standard interfaces for all the things under the sun. You got standard sound, we got standard keyboard and mouse, right? You don't have to install drivers for any of this stuff. We're going to define a standard. That standard does not include the CTS flow control signal, clear to send. It includes all the other flow control signals, but not CTS. There is no way to trigger a CTS using the CDC standard USB protocol. This is why when you get an FTDI serial chip, you need to install a driver in your operating system because they are not using the standard. They can't use the standard to implement a full RS-232 interface. So they have to implement their own USB protocol, and you have to install a driver in the operating system for this to work. So the USB specification lacks the ability to trigger this one flow control signal. Guess which flow control signal is the one flow control signal that Smart SDR for Windows uses to trigger a PTT. The only flow control signal that they will look at is CTS. The one signal that I cannot trigger with a microcontroller over USB. So Halibut V1 will work with Smart SDR for Windows and Smart SDR for Mac, but not remote ham radio, not Smart SDR for iPhone or iPad or any other future application that I may want to implement it for. Halibut V2 will work with all of those applications, but not Smart SDR for Windows.
Oh my God.
Because it doesn't. Is that because it doesn't recognize MIDI?
Smart SDR for Windows does not do MIDI. They don't have a
Yeah, I
keyer
know.
built in. So the only thing that Smart SDR for Windows will do is a PTT. It'll use it as a
Push talk, yeah.
PTT. And the only way they can trigger the PTT is by triggering a CTS, the clear to send, on a serial port. And that is the one signal I cannot do on a microcontroller.
Have you
So-
seen the MIDI key that Aura N6ARA has.
So
It's
I
got
looked on his website just yesterday because I needed a new key.
yeah,
That's USB-C on one side and paddles on the other.
exactly.
Okay. Are you sure that's released?
Oh yeah, it's. I bought it off the site probably six months ago.
So while you're looking that up, Mark, Eric says, so if a serial cable is bad, does it go snap, crackle, pop?
If a serial oh, I got you. Wah, wah.
That's terrible, man.
Little IT humor there.
Yeah,
That's-
there we
that-
go.
Terrible. Focus is on little.
That's Eric for you.
I don't see that on his website right now.
Huh. I'll take a look.
So I did
Right.
talk to Ara at one point about like, could I license his paddles? Because I believe strongly that device needs to exist, right? USB on one side, paddles and key are on the other side. And when we were talking at the time, I'm like, all right, I'm not coming up with anything unique here. If you're not going to license me the paddles, then I want you to implement this. So I'm kind of glad to see that he has actually implemented that.
So Don wants to know, or says, ask Mark to tell us about the Universal Radio Controller.
The URC.
Hmm.
The Universal Radio Controller. Okay, so there was a bloke named Mark out in the UK who designed, he took the all-in-one cable. Y'all are familiar with the all-in-one cable? It's a USB port on one side, and then it's got like the two Kenwood things on the other side that you can use to program your radios, and it will also do audio in and out. So it's usually made into like a little tiny board that just plugs straight into the side of an HT. But he took that design, which is an open source design, and he laid it out into a relatively small board, about yay big, and fit it into an aluminum case and gave it all kinds of connectors on it, on the front and the back. So it still has the 3.5 and 2.5 millimeter connectors that go directly to a Kenwood radio. Kenwood, whatever, any of the common inexpensive radios, they all use the same
Balfang, TID radio, talk
Yeah.
pods, yeah.
all of those. They all use the same physical standard for their speaker mics. That's the word I was looking for. But then he's also got just dedicated, mic and headphone ports. And he also added OHIS ports on it, the Open Headset Interconnect standard, which is a thing I'm working on. And he was selling it in the UK, and it was selling reasonably well. And then he said, I would really like to sell this out in the United States or out in the rest of the world, but I don't want to deal with having to ship to the rest of the world. And I already deal with shipping to the rest of the world. So he just gave me access to the design and said, don't bother paying me or anything like that. Go sell this and make it available to the rest of the world. And so I do. And I've got a bunch of them on the shelf, and it's a neat little project. He's got a daughter board in there that it comes with just a whole bunch of holes on there that you can prototype and do whatever you want. But he also sells a board that is a TNC. It uses a STM32 microcontroller and runs some firmware. I can't remember exactly what it's called, but it's a TNC, right? So you got a serial port out to your computer on one side, and the audio goes through all of the other audio interface out to your radio. It's a neat little kit. USB, and then any of the audios to your devices.
All right. And as we wrap down here, because Ham Nation is up next, and we're going to have a hard cut here in 9 minutes. Will version 2 work with remote hams? Asks Chris over on Vince's chat. So
remote hams. I don't know about remote hams. I know about remote ham radio, RHR, and it will work with them. I've sent one off to Rocky and or Rock, excuse me, and he has been doing development with it, or at least several months ago he probably hasn't worked on it in a while. But the idea is to make it work with them. Remote hams, is that a different thing?
I think so.
Okay, remotehams.com. I would have to go take a look to see whether it'll work with them. But if it's something that I can implement in the firmware, I will happily add it.
So, Chris, I'll make a note of that. Spoiler alert, I'm going to have Mark on my channel here sometime soon. So come by my channel, and I'll have a follow-up, hopefully, from Mark at that point.
Yeah, awesome,
Sounds
guys.
good, Mark?
Mark,
Yeah,
thank you very much. You are definitely a wealth of information on a lot of this stuff. And where can people find you online, just in general?
I'm most active on Discord these days, the Ham Radio Workbench podcast Discord. Ham Radio Workbench, I do with Vince and several others. We drop a podcast every 2 weeks on Tuesday mornings. I will sometimes poke my head into Mastodon. I am at smitty@halibut.com there. But I don't really use any of the other social networking stuff anymore. It's too much of a hellscape these days. And for my own sanity, I've narrowed down the communities that I interact with more often. So Discord, hop into the Ham Radio Workbench Discord there. You can get an invite link on hamradioworkbench.com, or you can just send me an email, mark@halibut.com.
Vince also just dropped a link in both chats. So
Awesome.
Well, thank you. So we got a few minutes here. We can go around the room. Frank, 30 seconds.
Thursday night, NorCal Swap. Friday, between Mike doing his giveaway and late shift with Digital Rancher, I'm going to sneak in a Q&A AMA, so come on by and see that. And, well, I'm working to get Mark on the show. Might do a Monday night somewhere before TO goes live with Nuggets. That's about it.
Oh, my gosh. He actually got it done in 30 seconds.
I have no idea what any of that means.
Man, Lord. Vince, what do you got going on, buddy?
Hey, I don't have a lot coming up on my channel. I've been dropping articles on qrper.com, and I am joining Mike N6MTS this Friday for his 3,000 sub giveaway, which is happening at 7 p.m. Eastern Time here on the tubes. That's what I got coming up.
Check your local listings. Times may vary.
Mm-hmm.
Yeah. Freddie Mac, speaking of subs, you just crossed over a big
9,000.
Man, that one snuck up on me, y'all. I tell you what,
Yeah.
it's been a whirlwind. But thank you, everybody. I think we're scheduled for November 5th. We're going to do a live stream right here on the Ham Radio Kids Table. I'm going to give away a couple of Spec 5 Meshtastic nodes. One of them is the Ranger Magnum. These items were donated by KI5NHD out there in Western Oklahoma. He's the president of the Oklahoma Repeater Society. And I'll get into more of him when that happens. But I got a video dropping tomorrow night doing a firmware upgrade on the new TID Radio TDH3 Plus. A lot of new features, some really surprising stuff that I didn't realize was there, but showed up after the firmware upgrade. So be sure and tune in tomorrow night for that.
Is that one do the APRS?
No, that's the TDH9. That's upcoming. It's a little more
Upcoming.
expensive than these, but
Okay.
Well, you can get them now, but you can't get them on Amazon yet. I don't know why that is. But the TID Radio TDH9 is.
I heard that Shane's trying to get his hands on an H9 to do a review, maybe.
Oh, I'm going to try. I just don't know if it's going to happen. But hey, it looks pretty cool.
Carlos, what do you got going on?
SSDD, this weekend is the last weekend of the skydiving season in the Midwest, at least where I work at. Highly unlikely that I'll do an amateur radio jump just because it's frigid, and I mean frigid up there right now. But I am prone to doing stupid and foolish things, so keep an eye on the Discord and all the other normal places if I do decide to be, to get frozen. That's where
He's going to bundle up, folks. Don't worry.
Wear your thermal underwear.
Mm-hmm.
It's the hands that get cold, man. It's the hands.
Protect those
Dude,
brass balls of yours.
Where are you keeping your hands? Thermal underwear. How does that work? Never mind.
I'm sure you can get
Come down.
you can get electric clothing and gloves that you can run off your HT battery on the way down.
I am sure that stuff exists. The problem is dexterity. I need to be able to put my hands in the controls for the parachute so I can fly it down safely.
That
Mm-hmm.
does seem like a good plan. Yeah.
Carlos, you're overthinking that whole thing.
I
man.
know.
Stupid gravity.
Gravity, golly.
Stupid gravity. I like it.
Jeff, what do you got going on?
Working on some videos, got some more ideas. I actually have a website, believe it or not, and I just can't get to editing anything to make it look nice. K3JRZ.com, but it's just like the basic stuff that the initial thing got set up. I haven't edited anything yet much, but eventually that will have some stuff on there. Video coming up, got to work on that. Really busy with work this week. We're missing someone, and it's like Christmas time. Everyone's requesting stuff, so been quite busy with stuff. So yeah,
That reminded me. ve6lk.com/shop got a facelift recently.
Ooh.
I don't know how you people do all this
And
web page stuff.
And all the tariff
quickly.
stuff got all figured out too.
I was going to ask. I saw Ham Radio rookie. Gosh, I can't think of his name.
Yep. Ben.
In his in his just recent email, he posted that he's able to bypass the tariff stuff now to get product inside the United States.
Bypass is the wrong word, but he's able to ship free of tariff because of the classification of his goods.
Gotcha.
We both still have to obey the tariff laws. Yeah.
Well, okay, yeah.
Last thing we want to be doing is saying on a live stream, "Oh yeah, we got a way around that damn
silly
thing."
laws. Yeah.
To try and save us from that particular topic, Jeff, I did want to point out that I can highly recommend not working for somebody else.
Oh yeah, definitely.
Yeah, it's worked really well for me. Unless you want to get paid, that hasn't worked out so well. But,
equation don't compute.
Getting paid is
I've been
overrated.
this for almost 4 years now, and I still only make about $100 a week.
Well, I thought about selling my body.
Yeah,
Kind of
That'll
thing,
make it
but
up.
Yeah,
we're
okay,
gonna work it out.
gotta keep this G-rated. Ladies and gentlemen, thank you for coming to the Ham Radio Kids Table. Please go visit Ham Nation. They are up next. I have been dropping the links in some of the chats.
Yep.
And I have to. See you
Don't forget, we got Thursday night videos dropping. Ham Radio, what is I started to say Ham Radio Clubhouse. Sorry. Coffee and Ham Radio is tomorrow night. All the Friday night live streams, Frank and Digital Rancher have got theirs going on, and then Saturday
and Mike.
And Mike. Yep. On Friday.
Oh God, yes, Mike. I forgot about Mike. So
Yeah.
until then, everybody, have a great night. 73.
See ya.
See ya.
You did.